In order to understand the universe, you must explore the universe. And that's the motivation to accelerate humanity's future in understanding the universe and extending the light of consciousness to the stars.
$16.8 billion is the opening check for a chip factory that SpaceX and Tesla say could grow past 100 million square feet. Not a data center, not a warehouse. A semiconductor complex in rural Texas, built for a future where Elon Musk does not want to wait in anyone else's line for artificial intelligence hardware. That is the TeraFab wager. SpaceX says the project will sit in Grimes County near Gibbons Creek Reservoir. The companies say it will combine logic chips, memory, packaging, and testing in one manufacturing system. If the full plan happens, it will be larger than any semiconductor project most investors have ever had to price into a story. The number that matters is not the floor space. It is the target behind it. 1 terawatt of compute hardware every year. A terawatt is 1 trillion watts. Musk's companies are not talking about buying a little more capacity from NVIDIA, TSMC, Samsung, or Intel. They are describing an industrial machine built to pull chip supply inside the Musk ecosystem. That changes the way you should look at Tesla, SpaceX, xAI, Optimus, Cybercab, and Starlink. For years, investors treated them as separate bets. Cars, rockets, robots, satellites, artificial intelligence. TeraFab is the attempt to put a shared bottleneck at the center of all of them, silicon. That bottleneck is brutally expensive. Advanced chips do not appear because a founder wants them badly enough. They need mature process technology, lithography equipment, packaging capacity, water, power, clean rooms, materials, engineers, suppliers, and years of yield learning. The world's best chip makers built those capabilities over decades, one painful production ramp at a time. Musk is trying to compress that calendar. Tesla has been described as building a research fab at Gigafactory, Texas. SpaceX would handle high-volume manufacturing at TeraFab. Intel has joined the effort, and Musk has said the target process is Intel 14 angstrom. That last detail is the warning label buried under the headline. The plan depends on technology that is still moving from roadmap toward volume reality. The promotional version is simple. Put every stage of chip making under one roof, cut out shipping delays, control the supply chain, and make custom chips faster than competitors. It sounds almost inevitable when you say it quickly. It also skips the part where every stage is normally separated because each stage is hard enough to break a company by itself. A leading-edge fab is not a car factory with cleaner floors. A defect the width of a human hair is enormous on a chip. A tiny contamination event can ruin a batch. A packaging line that misses its targets can choke the value of a perfect wafer. Equipment arrives late, a process misses yield, or a power system slips, and the schedule is not delayed by a week. It can be delayed by years. That is why the scale is so revealing. The ambition is not merely to make a Tesla chip. It is to create a captive silicon pipeline for machines that do not exist at scale yet. Optimus needs a brain. Robotaxis need onboard inference. Space-based data centers need hardware designed for a different thermal and power environment. The factory is being justified by future demand as much as present demand. The easy explanation is that Musk is building the next great American factory because the chip shortage taught everyone a lesson. There is truth in that. The pandemic exposed how concentrated semiconductor supply had become. Governments and companies now talk constantly about resilience, but resilience is only the surface of this story. The deeper move is negotiating power. When a company depends on outside chip makers, it competes for allocation, accepts another company's roadmap, and pays another company's margin. When it owns more of the design and manufacturing stack, it can tune hardware around its own software, vehicles, robots, satellites, and energy systems. It gains speed when the rest of the market is waiting for capacity. That is the upside. The risk is just as concentrated. A company that pulls more of the chain inside also pulls more execution risk onto its own balance sheet. The project has been reported with a first-phase figure of $16.8 billion, while county filings and reporting have described much larger possible totals across later phases. Those are plans, not finished output. The official disclosures matter here. SpaceX's prospectus material describes a framework with Tesla and says specific projects still require separate agreements, timelines, capital expenditure decisions, and approvals. It also says neither Tesla nor Intel is obligated to remain part of the collaboration. That is not a reason to dismiss TeraFab. It is a reason to separate the announced ambition from the contracted reality. Look at what has already been secured. Grimes County approved a reinvestment zone and a tax arrangement for the proposed project. SpaceX has identified the site and says it intends to rely on the nearby reservoir rather than local groundwater, with recycling and treatment measures. Those are real local steps. They do not prove the final campus will reach every number now circulating online. The 100 million square foot figure needs the same discipline. It describes planned manufacturing space, not 100 million square feet of clean room. Those are radically different claims. One industry report notes that the company has disclosed very little about the internal layout. Until there are completed buildings, installed tools, qualified lines, and sustained yields, size is a proxy for ambition, not a proxy for chip output. There is a financial consequence to that distinction. A giant shell can photograph beautifully long before the expensive part arrives. The value is inside the tool set. The lithography systems, deposition tools, etchers, metrology equipment, packaging machinery, material contracts, and the teams that keep all of it stable. A completed roof is a milestone. It is not a working fab. A working fab is not a profitable fab, and a profitable fab is not automatically a source of world-class chips. This is the discipline the artificial intelligence boom keeps trying to avoid. Every executive can announce demand. Every investor can draw a curve from robots, vehicles, and data centers to more compute. The shortage only becomes investable when a specific factory turns design into repeatable output. That means yields. It means cost per good chip. It means packaging capacity that keeps up with wafer output. It means customers that can buy enough hardware at a price that supports the factory behind it. Musk's companies have an advantage most new fabs do not. They can create internal demand. Tesla can tailor a chip to its vehicles and robots. SpaceX can design around satellite workloads. xAI can shape software around the hardware roadmap. That can reduce the usual hunt for outside customers. It can also remove an external test. Captive demand helps a factory survive, but it does not remove the physics, the cost, or the challenge of matching a moving frontier set by competitors already producing at scale. The county deal adds another layer of accountability. Tax incentives are a public bet on private execution. Residents are being asked to look past the near-term exemption in exchange for jobs, infrastructure, and a transformed local economy. SpaceX has described thousands of jobs, but headcount targets are not payrolls and construction activity is not permanent employment. The fair question is not whether a community should welcome technology. The fair question is what milestones must be met before the public can judge whether this bargain is working. There is another pressure point investors should not ignore: power. A terawatt of annual compute hardware is not the same as a terawatt of electricity, but the machines built from that hardware will still demand enormous energy when they operate. Musk's answer stretches across his companies. Tesla builds storage, SpaceX launches satellites, Starlink connects machines. The factory could become the physical hinge between those businesses. That is also why the orbital data center language matters. SpaceX describes artificial intelligence satellites that would use solar power in orbit and laser links through Starlink. Whether that vision becomes commercially viable is a separate question, but it tells you the company is not planning TeraFab only for earthbound cars. It is trying to make chips part of a vertically integrated space compute network. The competitor transcript also points to a separate proposed Texas solar cell project called Project Crystal Sun, with a reported investment around $10 billion. Treat that one carefully. The filing described in the source material is an incentive application while Tesla evaluates locations, not a completed construction commitment. The important signal is the manufacturing logic. Wafers, ingots, coatings, and metallization would move more of solar cell production in-house if the plan proceeds. Put TeraFab beside that solar proposal, and the pattern becomes hard to miss. Musk is not only building products, he is trying to own the factories, the energy, the connectivity, the compute, and eventually the hardware that consumes all of them. That can create powerful flywheels. It can also create a system where one missed factory ramp affects several companies at once. Wall Street loves to value the visible product: a vehicle delivery number, a robot demonstration, a rocket launch. The harder asset to value is the industrial option being built underneath. If TeraFab works, Tesla and SpaceX could control a scarce layer of the artificial intelligence economy. If it struggles, the cost is not merely a delayed product launch, it is a strategic bet that burns capital, while the established chip makers keep shipping. This is where the story gets uncomfortable for the market. Intel is not simply a logo added to a press release. Its process technology and manufacturing experience are central to the premise. SpaceX is not simply a customer. It is carrying the high-volume manufacturing role. Tesla is not simply selling cars. It is expected to develop the pilot line and feed demand from autonomy and robotics. Every promised advantage relies on the others arriving on schedule. The numbers should make you skeptical and attentive at the same time. 100 million square feet is huge. 1 terawatt of annual compute is huge. A capital plan that could reach well beyond the initial investment is huge. Enormous claims are not automatically false. They are an invitation to ask the unglamorous questions. Which tools are ordered? Which process is qualified? Who owns the risk? What is the construction sequence? When do yields become visible? That is the gap between a moonshot and a factory. The press event gives you the blueprint. The supply chain gives you the answer. Watch for land work, county documents, equipment orders, Intel's disclosed scope, water permits, power agreements, hiring, and pilot line results. Those signals will tell you more than another rendering ever will. If you want to stay ahead of that signal instead of drowning in the hype, join the community. This is where we follow the filings, the manufacturing constraints, and the money behind the headlines together. The people who protect their wealth do not need every prediction to be right. They need to know which claims are already becoming concrete and which ones are still only a promise, because TeraFab is not really a bet on one building in Texas. It is a bet that the next contest in artificial intelligence will be won before the model runs, before the robot moves, and before the satellite launches. It will be won in the factories that decide who gets the silicon. That is where smart money history gets written. I'm Andrew. Stay sharp.